Now, now look at equation number 3. Can we write equation number 3 as shift this u1 on the other side, so it will be minus. So v1 will be equal to v2 plus u2 minus u1. So this is the value of v1. Okay. Now put this value of v1 in equation number A. This equation is called equation number A, which is law of conservation of momentum. This is the equation of law of conservation of momentum. So putting this value of v1 in equation number A, so it will be okay. Wait a minute. So it will be okay. I'll write it here. M1 U1 plus M2 U2 is equal to M1, and putting the value of V1 here, so it is V2 plus U2 minus U1. Okay, now plus M2 V2 as it is. Okay, now multiply M1 inside, so it will be M1 U1 plus M2 U2. Okay, multiply M1 inside, so it will be M1 V2 plus M1 U2 M1 U2 minus M1 U1. Okay, so I multiplied M1 inside plus M2 V2 as it is. M2 V2 as it is. Okay, now look, combining the similar terms with one another. Okay, look at here. Here we have U1 term, and here we have U1 term. So shift this U1 term on the left hand side. So it will be M1 U1 plus M1 U1. Okay, yes. Here we have U2 term, and here we have U2 term. So shift this U2 term on the left hand side. So it will be M2 U2 minus M1 U2. Okay, now look at here. This term is V2 and this term is also V2. So taking V2 as a common between them, so take V2 as common between them, so it will be V2 into M1 plus M2. Okay, now M1 and M1 both will be added, so it will be 2 M1 U1 plus, take U2 as a common, so it will be U2 M2 minus M1. Okay, V2 M1 plus M2. Now divide M1 plus M2 on both sides, so we will get the value of V2. So it will be 2 M1 U1 divided by M1 plus M2 plus M2 minus M1 into U2 divided by M1 plus M2. This is the value of V2. This is the value of V2. V2 means the velocity of mass M2 after the collision. Now, we are going to find the velocity of mass M1 after the collision. So, let us consider equation number 3 again. So, equation number 3 is U1 plus V1 is equal to V2 plus U2. Okay, now shift U2 on the left hand side, so it will be U1 plus V1 plus minus U2. This is the value of V2. Okay, putting the value of V2, V2 in equation number A. This is actually the equation number A. Look, this is the equation number A, which is the law of conservation of momentum. Okay, putting this value in this equation. So first I'll write that equation here, then we will put it m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, now putting the value of v2 here, so it will be m1 u1 plus m2 u2 is equal to m1 v1 as it is, and putting the value of v2 here, so it will be u1 plus v1 minus u2. Okay, now multiply m2 inside, so it will be m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u1 plus m2 v1 minus m2 u2. Okay, now combining the similar terms, so look at here, there is a term u1, and look at here, there is another term u1. So shift this u1 on the left hand side, so it will be m1 u1 minus m2 u1. Okay, now look at u2, here there is a u2, and here there is also u2, so shift this u2 on the left hand side, so it will be m2 u2 plus m2 u2. Okay, now look at these terms, take v1 as a common in these two terms, so take v1 as a common, so it will be m1 plus m2 into v1. Okay, now look at here, take u1 as common in this equation, so it will be m1 minus m2 into u1, and they will be added, so it is 2 m2 u2 is equal to m1 plus m2 into v1. Okay, now divide this term on both sides, so we will get v1, that is m1 minus m2 divided by m1 plus m2 into v1 plus 2 m2 u2 divided by m1 plus m2. This is the velocity of mass m1 after the collision. Okay, these are the calculations in the topic of collision in one dimension. So if you have any query, any questions, so you can ask in comment section. Okay, take care. Allah Hafiz.